This lesson is a whole lot like the one we just did, and if you want to pause and read these bullet points, you'll see that they're pretty much the same bullet points that we had on the last lesson. But one of the things that I mentioned to you that we'll just formalize here is that if you're looking for the midpoint between 2 points on our number line, you just average them, add them up, and divide by 2. So you'll see why that's important in just a second. So what I want to do is to find the midpoint between 13 and 3. We'll just add them up. 13 plus 3 is 16. Divide by 2 is 8. Here's the hard way to do that. The hard way to do that is to say, here's 3, here's 13. That's a distance of 10. Divide 10 by 2 is 5. And if I moved in 5 from the left, or moved in 5 from the right, where would I land? Well, 8. But averaging just gets you there instantly. So to find the midpoint between negative 10 and negative 2, just add them up and divide by 2. Negative 12 divided by 2 is negative 6. Negative 13 and 5, I'm just testing your negative arithmetic right here. That'd be negative 8. And then divide that by 2, it'd be a negative 4. Oh, but what about odd numbers? Negative 13 plus 4 is negative 9. And what is negative 9 divided by 2? Well, oddly enough, it's negative 9/2. Now, on a graph, you would want to see that as a negative 4.5 or a negative 4.5. But mathematically, we'd always prefer just to leave things as their pure fractions. So, how would that work? You'll notice that if we're looking for the zeros of a function, then we would simply want to ask what x value input causes the y value output to equal 0. So it'd be asking what x values give an output of 0. Oh, do you notice that this is factorable? X minus 6 times x plus 2. So just like in our last lesson, we know that our zeros are going to be 6 and negative 2. And if we average those, negative 6 plus 2 is negative 4 divided by 2 is negative 2. That doesn't make sense. What did I do wrong there? Oh, I see what I did wrong there. That was my bad. So when I add them together, 6 plus negative 2 is negative 8 divided by 2 is negative. Oh, that doesn't seem right. Oh, I know what's wrong. Sheesh. Now, let's find the other information. Obviously here we have those two zeros at 6 and negative 2, but where's the midpoint? So let's add them up and divide by 2. So that would be 4 divided by 2 is 2. And just to note, that's 4 units to the right to get to 6, 4 units to the left to get to negative 2. The axis of symmetry is right there. But what about the vertex point? Well, all I have to do is to evaluate f of 2 and I'll know. Now I can do it one of two ways. I can input it into the original function, but I'm going to do it a different way. I'm going to do it in the factored form because I think I could do it with easier mental arithmetic in the factored form. This would simply become negative 4 times 4, which is a negative 16. So the vertex point down here is at 2, negative 16. And my vertex, I have an upward opening parabola. So there's my graph. So all I was supposed to do is to give a simple sketch of the function and label the vertex, the zeros, and the y-intercept. That y-intercept is right there. So 0, negative 12. Notice that if you input 0, that all these terms fall to 0, and I have the input of a 0, the output of a negative 12. So On this 28, you should recognize the 7 times 4 factoring of the 28. So I know quickly that it factors as an x minus 7, x plus 4. That makes my minus 3x. That gives me zeros at 7 and at negative 4. So there's 7, there's negative 4. If I add them up, I get 3 halves. So that's my point right there at x equals 3 halves for the line of symmetry. Now, how do I find my vertex point? You have to ask yourself the question, would you rather evaluate 3 halves in the original function or in the factored form? I'm going to go factored form. And here's the reason that I would do that. I'm going to do 3 halves minus 14 halves. And all I did was re-express the 7 as fraction with denominator 2 times 3 halves plus 8 halves. And again, all I did was express the 4 as a fraction over 2. Then I would have negative 11 halves times positive 11 halves. I'm sorry, I said halves. What a doofus I am. Oh, no, I'm all right. Because I had the common denominator. I'm thinking one step ahead. When I multiply, I get negative 121 over 4. So that would be 30.25 if you ran it through a calculator, but would really prefer to say that this is an x value of of positive 3 halves and a y value of negative 121 over 4. In a science class, would obviously call that a 1.5 and a negative 30.25, but there's our graph. The only other thing we need to know is, what is this point right there? We already know. X value 0, y value negative 28. So we were able to do that evaluation and that sketch with relative ease and pretty quick order because of the factoring form of each of those parabolas. Now, you remember the old quadratic formula, and I've said this in class and said it in the last video, that the old quadratic formula, when you work it on the basis of completing the square, that the negative b over 2a is the axis of symmetry. The parabola lives, or the vertex of the parabola lives on the axis of symmetry. And that plus minus part right there tells me how far it is from the axis of symmetry to the 2 x-intercepts, the zeros of the function. So let's use that concept to see if we can break this guy down. So the first thing I'd say is that the axis of symmetry would be x is equal to negative b, negative 14, over 2a, negative 10, which could be simplified to 7/5. So with that in mind, I know that my graph is downward opening, and I can get more information out of that. I know it has an intercept at positive 10, so at 0, 10. It has an axis of symmetry over here somewhere at x is equal to 7/5. I know it's downward opening, so it must look something like this in order to accommodate the downward opening and to pass through that y-intercept at 0, negative 10. So I need to find out where those 2 intercept points are. Now I'm going to do this in a way I could use the quadratic formula. I'm not afraid of the quadratic formula. I just want to show you another option. The other option is this. I know that if I could put it into that graphing form, it would have a negative 5 multiplier because the negative 5x squared when it expands. And I know that its axis of symmetry is at 7/5. So that means I need a right shift of 7/5. Now at this point, I'm just going to expand and see what happens. And I can do this in my head, but for you, I'll do the work over here in some scratch area right here. So I'm going to say first term squared, x squared, times negative 5. Yes, I did it. Twice the product. Well, I'm going to take x times negative 7/5. I'm going to double it, and that's going to become negative 14/5 x. And then I'm going to multiply that. Remember, I have to distribute the negative 5 into that result. The negative times the negative is the positive, and the 5's cancel, and lo and behold, out pops plus 14x. Now, I would have so much confidence, I wouldn't even worry about that. I'd know that that's what was going to happen. But here's the real question, and here comes the Goldilocks question. First term squared, twice the product, second term squared. When I square that second term, I'm going to get 49/25, but I still have to multiply that times negative 5. And that would give me negative 49/5. 49/5. Now, I'm quick enough to see that that is actually negative 9 4/5. So, after I get that negative 9 4/5, how do I get negative 9 4/5 up to a 10? Well, I add 19 4/5. Now, correctly, I would be better off to call that negative 19 4/5 99/5. So 99/5 would be the equivalent of this. Now, when I try to find the zeros, and I use that 99/5, here's what's going to happen. I'm going to subtract the 99/5 to the other side. And then I'm going to divide by negative 5. That's like multiplying by negative 1/5. That becomes 99/25. And then I have the x minus 7/5 still squared. Now I take the square root. So I'm going to take the flow over here. The square root of 99/25. Well, the square root of 25 is a 5. 99 is 9 times 11. The square root of 9 is 3. The square root of 11 won't simplify. Don't forget the plus minus. Equals x minus 7/5. Now add the 7/5 to the other side. And this is what you would have gotten had you done the quadratic formula. You'd still have to wrestle with some pretty ugly numbers, but it would be 7/5. Notice that that's my axis line at 7/5 plus or minus 3 square root of 11 over 5. That 3 square root of 11 over 5 is the distance between that axis line over to its two root points, to its two x-intercepts. So if I was going to talk about the zeros of the function, I could do it like that. If I wanted to, I could say it would be 7/5 plus or minus 3 squared 11 over 5, 0. Those are the x value inputs that create a y value output of a 0. So either one is fine, but notice that I can get all the information out of my equation just by doing a few simple things. Oh, by the way, I guess we should name this vertex point here. It was 7/5 and a y value of 99/5. And again, notice that that y value 99/5 is just nearly a 20. And so it would be coming down pretty steeply because of that negative 5 coefficient on the x squared. And so it makes sense that it would cross the y-axis at 10. It all seems to confirm. Now, there are some times that it just gets so ugly, you just got to have a calculator. And so with a calculator, I would simply put in axis of symmetry. X is equal to negative b, so that'd be positive 3.2, divided by 2a, which would be 5. Now, in my head, I can see that that would be 32, I'm sorry, that would be, I'm going to double top and bottom, that'd be 6.4 over 10, which would equal 0.64. So just a little bit right of the axis is the line of symmetry at x is equal to 0.64. Well, what about that y value? So on my calculator, here's what I would do. I would type 0.64 store as x, and then just turn right back around and type 2.5 x squared minus 3.2x minus 8.5. And then out would pop a number. So I'm doing that right now. I'm storing the 0.64 as my x value. And then I'm typing the original equation, 2.5 x squared minus 3.2 x minus 8.5. And when I tap enter, I get negative 9.524. I now know where my vertex is. It sits below the x-axis, and it has an x-coordinate of a 0.64, and it has a y-coordinate of negative, oh, darn it, and it has a y-coordinate of negative 9.524. Now, I could use my quadratic formula, but what I'm going to do instead is I'm simply going to use my solver. So I'm going to put the original 2.5 x squared, etc., into my y1, and in my y2, I'm going to put 0, because as I find these 2 points here, I notice that the y value there is 0, and I'm looking for the x value. And then I simply go to my solver, and it should already be set up for your calculator to have that y1 and y2, and we're comparing the y1 to the y2. Now, I have to make my guess, and my first guess is going to be anything to the right of 0.64. So I'm going to use like 1, and when I use a 1, I get a 2 point, how should I round, nearest hundredth? I get 2.59. Now I'm just going to turn right back around and reset my guess to something left of 0.64. I'll just use a 0. And this time when I solve, I get negative 1.31. So I've got my vertex point, I've got my x-intercepts. The only thing I don't have is my y-intercept, and that was given to me right there. So my y-intercept is x value 0, y value negative 8.5. So those are all the critical things that I need to know about any graph. Where are its vertex points? Where does it intercept the y-axis? Where does it intercept the x-axis? And I could have done this same technological approach on the previous problem, but I was trying to tie it to the quadratic formula and the completing the square concept. On this one, I just treated it like a science problem and just let the calculator do all the heavy lifting. So now you'll have a few problems that you get to use and practice on this skill. Good luck.